All right, so welcome back to another example of kind of ordering things up. So in this example, so you have how many arrangements can we make from the letters A, B, C, D such that B is never beside C or D? Okay, so this is not an easy one. And I'm going to do it kind of two different ways. Because we only have A, B, C, D, which is really just 4 letters, I can use the brute force way. Now, the reason why I'm going to do the brute force way is because then I'll try to give you an intuition of how to think about the problem, all right? So that you can extrapolate it to harder problems. Okay? And then I'll make another actually video exactly kind of the same, but it's going to be more. Okay, it's going to be bigger so that we can't use brute force anymore. So we have to have some kind of an intuition. Okay, so let's try this. So what this says is we want to know how many arrangements, there actually won't be too many because we have just 4 letters, where B is never beside C or D. So they can never be beside each other. Okay? So now let's try this. So in how many different ways can I rearrange all of them? Okay, so I'm going to kind of take it and rewrite in brute force ways. I'll do it kind of in fast forward fashion, but I'll just do all the arrangements possible. Okay, let's do that first. All right, so it took a little bit because we have to go through all the different arrangements we can have. So we know that this really would have been 4 factorial ways, right? So we have 4 factorial ways, which is 24 ways that we could arrange these letters. And here they are. So if you put A first, B first, C first, D, okay, so it's 6 each, so 6 times 4. Is the 24. So that's the total 4. Now, what they're telling us that B, okay, right here, is never beside C or D. Okay, so what I'm going to do, and I'll switch the color just so that we can see it. So we're going to first, find out, so when is B, okay, actually beside C? All right, so this can happen either BC, okay, or 2 factorial ways, or CB. All right, so this is 2 factorial ways, or just 2 ways. Now we can just swap these, okay, and that's going to now leave us. So if we have them together, right, then that leaves, I guess, the A and the D to float around as it likes. So we have basically 3 units. We have the B and the C, okay? And then we're going to have the A and the D. And this, in total can be 3 factorial ways rearranged. And then multiplied by that 2. So it's going to be 2 factorial times 3 factorial, so this is going to be 6 times 2, which is equal to 12. So there are 12 total arrangements where B and C are actually together. So let's find them. Okay, when is B and C together? So I'm going to put a check mark. So B and C is here. It's not in the second one. Okay, here it is again. So C and B, so either one or the other. It's not in that one. B and C, so here again, C and B, here again, so that's 4. All right, so now B and C, that's right here. B and C right here. None there. Okay, so B and C, so right, that's right here, right here. That is it. Okay, and now again, so B and C. Okay, C and B, B and C. Okay, and that. So that's a brute force way, right? And now in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so it's exactly what we would have counted by just using our intuition. Okay, and how many different ways can I rearrange these? So that's 12 total ways. Now, it also says that B can never be beside D. Okay, so I'm going to switch the color just so that, again, we can see it. So B can never be beside D. So this can happen like this. So either BD or DB, which just comes again because there's only 2 letters. So 2 factorial or 2 ways. And once again, you know, how many ways can I rearrange this? So if I group this as one unit, and then we'll have A and C right here. So these are 3 units, so 3 factorial ways. So again, so, you know, 2 factorial times 3 factorial. So in total, you know, 12 ways that we would have this. Okay, now let's find them. So that was B and D together. Okay, so I'm going to do it beside. So when are B and D together? So they're right here. B and D right here. B and D, so right here. Okay, right here. So that's 4 ways, B and D. And, okay, B and D here and here. Okay, so that's right here, B and D. That's right here and right here. And finally, the last one, B and D. Okay, right here. Okay, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's exactly what we wanted. Now, the reason why I wanted to show you this brute force, because oftentimes when students do this, the approach is, and it's a correct approach. So what you would do is you would find, okay, what is the total number of arrangements? Well, in our case, it's 24. And then you would want to subtract. So you would want to subtract, so minus. When are, you know, B and C together? So we found, so that was 12 ways, right? And then minus again, you know, when are B and D together? But that's also 12 ways. So if you notice, you'll get 24 minus 12 minus 12, which is going to be 0. So what has gone wrong? Well, what has gone wrong is, because if you notice here, you're actually counting certain things 2 times, right? So here, you know, B and C, or C and B are together, and B and D are together. So you've counted them twice, right? And that happens, now that's why I used kind of 2 colors and the 2 check marks, because we can go along within here and then see that, okay, how many times have I counted them up? Okay, again, so that would have been 1, 2, 3, 4. 4 ways that I've double counted. So if you're going to be using this method, which is a good method, I use this method. So the total minus when they're together, okay, there is an overlap. Okay, so it's almost like, you know, you have, and this will come back to you when you start studying Venn diagrams, you know, when, because you have an overlap between, so B and C and then B and D, and they do overlap, which means that you're actually going to be counting them twice sometimes. So in that case, we actually, when we say total minus when B and C are together, minus when B and D together, we have to now say plus, because we have to add back what we subtracted 2 times, right? So now plus, okay, these particular cases. So this would have been, you know, 1, 2, 3, 4. Okay, so when that happens, okay, so plus, okay, whatever I counted twice. And that would have been 4. But now, how do we come up with this 4 in terms of an intuitive amount? So what do we have to think about? Well, we have to think about, okay, the cases when we have, notice in all of them, Okay, the B, so when we have the B in the middle, and then, you either have a, C here and a D here, or you're going to have B in the middle and then a D, okay, and a C. Because in these two cases, okay, B is going to be beside C and it's going to be beside D in both ways. And now that, of course, so this now acts as one unit, okay? So this acts as one unit. We have two different ways of arranging, of having this around with B in the middle. Okay, so the only ones that can swap are the C and the D. The B can't swap with any of them because then it's not going to be counted twice. So when that B is in the middle, so this happens 2 factorial ways, right? And then, okay, you still have that A, which can be, so either in the back, okay, or it's going to be in the front. So there's two units, 1 and the A. Okay, so that is 2 factorial ways. So this is going to be times 2 factorial, or 2 times 2, which is just 4. And that's where this 4 comes from. So we have to add that back because we subtracted it 2 times. And oftentimes, sometimes even in the solutions in textbooks, they forget about this, that they actually have subtracted it 2 times. So in total, if we had this, if we did this entire thing, the answer is actually 4. There are only 4 ways, so coming back to the original question, that you can arrange the A, B, C, and D such that B is never beside C or D. Okay? Now it's a difference, if they say B never beside C and D, okay? But when they say or, we have to go through this entire process. And yes, that's indeed. So if we go in here, by brute force, was there really 4 ways? Well, indeed, so here's 1, here was 2, okay, so that was just 2 ways here. I guess this is 3, and then this is 4, and that is true. Those are the only arrangements, right, that we had, and that was my answer. So this is a very long solution, but I wanted to give this so that you can actually get a nice and decent example, okay, out of this. And then I'll do kind of one more, which is not going to be just 4, it's going to be much bigger. Okay, that's it for this question.